All right, back again for day 3 of Advent of Code. I also went ahead and solved day 4 of Advent of Code today because today is December 4th. So at some point I'll catch up and I'll record a live video of me working through the problem as I'm solving it. But for now, we're just gonna be rewriting some solutions, kind of from memory and just walking through how they work. So day 3. Gear ratios. So again, I don't really read most of this. I read it once, but I'm not going to read it now. So basically, you're given a puzzle input that looks kind of like this, and what this is it's a list of part numbers in this engine schematic, and basically what you're trying to do is any number that is adjacent to a symbol, even diagonally, is a part number and should be included in the sum. And then periods do not count as a symbol. They're just used as a spacer. So, in this example, we have the number 467 is adjacent to this star, and so it is included in the part number list. Whereas 114, if we look at all the squares around it, it is not a part number because it does not have any non-period cells next to it. So we have to find all the part numbers and find the sum of all of these part numbers. That is the first thing. Now, when I first tried to solve this, I thought that only the 7 was part of the part number, and so I thought that it was like 7, 3, and 5 are all next to this, and then 6 and 3 are next to this one, but not this 3. That is not how this works. They are actually multiple digit integers. So let's get the puzzle input. Of course, as usual, it's a lot bigger than normal, but that's okay. So I'm going to create a day3.onyx and a day3.txt. We're going to put in that puzzle input. Okay, so day3.onyx. Let's just get going right into the solution for this. So the first thing I'm going to do after creating the main is I'm going to get the contents, right? Typical stuff, inputs day03. And then I really want to turn this into a kind of a 2D array kind of thing, because I'm thinking I want to have some kind of board. Now obviously I'm going to do some more work over here to make this a proper board, but what I want is something that's like I do subscript y, subscript x, and that gives me the cell at xy, right? That's the kind of thing I want to go for here. So the way I'm going to do this is I want board to be effectively a slice of string. Not of string, a slice of bytes, right? And of course, I can't assign a slice of bytes to a slice of bytes like that. But what I can do is I can use that split iter function that we've used in the past days, but I'm going to use it in a slightly different way this time. So I'm going to use something called, if I can type, the pipe operator. So the way the pipe operator works, my editor's doing a fancy thing where it's replacing it with a this little triangle, but what it actually is a vertical pipe and then a less or a greater than sign to sort of form this like arrow, which is why the editor has the fancy ligature that turns it into a proper arrow like that. But what this does, if I just write this out, is it takes the result of what's on the left-hand side of it, in which case that's the previous part, the statement right here, or the expression I should say, right here, and it pipes it into the first argument into the call on the right-hand side. So if you have something that looks like f of a, b, c, you can turn that into piping a into f of b, c. So there's no other currying you can really do here. You can only like extract one argument out, but it's really nice for these kind of things, because you might be wondering, well, why would I write it like that? I could have just called split iter of the thing. But there's actually one more thing I'm going to do here. That's another pipe, because right now I have an iterator over strings, right? Because split iter produces an iterator over each thing. But what I want is a slice of those things. And so I could use the iter.collect function. And iter.collect only has one overload right now. It's the toArray function. But it does exactly what you would think. It makes a dynamic array and pushes all the results from that iterator into that dynamic array and then returns it. I guess I'm just realizing now I could also use the string.split function, which I'm going to just call just so I can go to definition for it. Oh, that's a lie. Oh, maybe it's because I don't use the return result. What? That's a lie. Because this also produces a slice of strings, which is a slice of bytes. But this is fine. This shows kind of how to use the pipe operator a little bit. All right, so we have our board. And so now we need to loop through the whole board. And we need to have a mechanism that finds all of these numbers and a way to test if those numbers are next to a symbol. Okay, so well, at the start we're going to need a for loop that loops over every line. Then we'll have a for loop that loops over every character. So the way I'm going to do this is I'm going to say for y from 0 up into board length, right? I don't remember if I don't know if I've actually used a for loop like this before, but the way these work is it's inclusive on the lower bound. So y is going to go from 0 up until board length, but it actually stops 1 less than board length. And the reason for that is, well, exactly this. This is a much more common case where I want to go between 0 and like 1 less than an array length. And so if you write 0 to 10, it's actually going to go from 0 up into 9, including 9, but it will not do 10. And so it's equivalent to like a for loop like this in C, where you have like 0, y less than board length, y plus plus, right? But a little bit terser in Onyx. So I'm going to do the same thing, but this time I'm going to, just for good measure, loop up until board y dot length. All right, so now I need to, let's see, I want to do if the board at a particular cell, if that is a number, we're going to have to do something special. So really what I'm actually going to do is I'm actually going to do the opposite. I'm going to do if it's not a number, just continue. Right? If the current cell we're looking at is not a special like number like this, we're not going to do it. We're not going to include it. So if we think about the way we're iterating over this, we're going down the lines and across the rows. We're always going to hit the first character of the integer first, right? If that kind of makes any sense. So we're always going to hit like this 1 of the 12, and then we'll parse the 12, right? Or then we'll like, I think you see what I'm saying. Like we're going to hit the 1 before we hit the 2 because of how we're iterating over this. So we can actually just use a little trick here. Because we're going to need to, at some point, extract that number, right? Whatever number we're currently on, we have to extract it. So the way I'm going to do that is by using that parseInt function we've used before. And I believe we've used the slice operator, but if not, that's okay. I'm going to parse an int from the beginning of the current line, starting at the current position up until the end of that board, or end of that line. So what is this really doing? So let me see if in day one I explained the, yeah, I did. Awesome. So if you remember from day one, we used this to like slice off just the ending part of a string. I'm doing the same thing here. It's just a little bit more confusing because now I have to first get into that line, and then I say from the X character until the rest of the line, I want to parse an int. Okay, so I don't want to modify this, so I'm not going to pass it by pointer, in which case parseInt will leave our string unmodified. It'll just return the number that it finds at that point. And we are using parseInt, so the fact that there are periods won't really affect it. We do need to figure out the length of it, though. Right? So I'm going to be a little bit cheaterish. I'm going to say the length is starting at 0. And I'm going to say just if the number is less than or equal to 9, the length is 1. If the number is less than or equal to 99, the length is 2. If the number is less than or equal to 999, do length is 3. Because I think that's the biggest number in here. I don't think there are any that are larger than 3 digits. So this, I'm going to label this as a hack. It's not a great way to do this, but it should work for this problem. Okay, so we're getting the length of our string, or the length of our number. We know our number. So now we have to look at all the cells around that number and see if any of them are a special character. And if they are, we can, we can add it to our list of things to sum. So I'm going to write a function for that. I'm going to say, I'm going to call it, I don't know, like neighbors contain special characters. I'm going to pass in the board, and I'm going to pass that in by, just not by pointer or anything, just like that. And then I'm going to pass in the X and the Y that we are currently at. All right. So let's look at how we can write that. So the board, again, is that slice of bytes. And then our X and our Y are both integers. So I can do it this way. To mention this here, if you have a type that is the same for like 2 arguments that are right next to each other, you can actually just omit it here. I could say this, but it's equivalent to just say this, which is to say that X and Y are both I32s. Just a little bit of a shorthand and a little bit of a convenience. Okay, so we need to find if this is true. So this is actually going to end up returning a bool to see if any of the neighbors contain special characters. And so we need to do that loop. So what is that loop going to look like? Well, if we think about it, we're going to iterate over 3 different rows, right? Because if you're looking at it, you have like, if you have a number like this, there's 3 rows worth of things that you could be at, right? Because you could be in any of these cells. So there's only 3 rows we're ever going to have to do. And they start at y minus 1, and then they end at y plus 1. So I'm actually just going to iterate from -1 to really +1 here. And I'll do some bounds checking to make sure we don't go outside the bounds of the board. And then for the column, what we really want there is the length of the number. Right, so our X and Y are going to be the first character here, but we want to know how long this number is, because that's going to be important. And so we'll pass in that length. I hit Control Z. 1 second. -1 to 2 for column in 0 to length. It's actually really going to be -1 to length plus 1. All right, and then I pass in the length down here. Okay, so we're going to check all of these cells, and really what we're going to do here is we're going to say, the first thing I'm going to check is make sure we're not going out of bounds. So if X plus the column offset If that's less than 0, we're going to go out of bounds. The other cases are if our y plus our row is less than 0, we're also going to go out of bounds. If the x plus the column is greater than or equal to the board, I'll be a little hacky here, and I'll say subscript 0.length, which is just going to be the, we'll make a variable for that actually. So we're going to say the width of the board is pick like the 0th thing, and say that it's, just get its length, and then the height is just the length of that board's list. That's how many rows there are. So in this case, we're actually just going to say if that's past our width, or if the y plus the row is greater than our height, then we're just going to continue. Right? That's our out of bounds checking condition. The next thing we want to do is we want to skip over, well, it actually won't really matter. The way our code's going to work, we don't really care if these are our numbers. So we're going to say, I'm going to call it like XX is our current cell we're going to care about. And now that I've wrote these, I think it'd actually be better to refactor the line right above. Not really refactor, but just clean it up a little bit. Just say XX is the cell we're targeting on X. We have YY in those places, just like that. Okay, so now we're going to say if the board at YYXX, if that is a number, we're going to continue. Because if it's a number, we don't really care about it. Or if the board at YYXX is a period, we also don't care about it. But if it's any other character, it doesn't matter what else it is. If it's any other character, we're going to return true. Because that means that we found a cell that isn't a number or a period, right? And so we'll return true from here. And that's going to tell us that there are special characters. So now we just have to use this function. We're going to say if the neighbors contain special characters, well, we know it's included, and we know we're just taking a sum of all these numbers. We're going to say sum is 0. If it worked, we're going to add in that number, and we're going to print part 1 is that sum. Of course, parseInt, like we've seen before, returns a 64-bit number, so I'll just make sum a 64-bit number. That's perfectly fine. And I actually don't even need to initialize it to 0. So let's run our day 3 solution. See if it worked. All right, and I got 581825. 581825. And let me wait for my Chrome browser to stop freaking out. And for the first part, doesn't look like that was quite right. Puzzle answer should be a little bit less than that. So, where did we go wrong? Let's think. So, one thing I want to do is when we find a number, let's print a couple things. Let's print out the number and then the cell that we found it at. That'll be kind of useful. Oh, I actually know what the issue is. I'll show you this because it's useful for debugging, but here's what happened. Let's actually pipe this to less so we can see this a little bit easier. So we found that 1, and we said that 1 is included, but then at the next cell over, we found a 2, which is not correct. Well, it is correct, but it's not correct, because as you can see for like 953, we're finding 953, or 935, 35, and 5, right? But that's not what we want. So as a sort of another hack I'm going to do, and I'll do this maybe after this if statement, it doesn't really matter where, but I'm just going to do a little for loop here. I'll use maybe m as my iterator. I'm going to go through the whole length of our number, and I'm just going to say board at that y at the x plus m. So we're going to walk through the things in the column, and I'm just going to change it to a period. Right? I'm just going to say we're going to clear out all of that stuff, which gets rid of that number. Okay, so this made it a little bit better, but it actually didn't fix the problem. Not entirely, at least. So let's actually put this back, and we'll look at why it's still not working. And let's actually also only print the number if we do detect that it contains it. Okay, so we got 12, which is good. We got 935 because it was there. We got these two, which are good. We got this one. Let's find one that shouldn't be there. The 652. Shouldn't be there. Oh, and it's not actually. We got the 6. That's good. We got the 904. Okay, next row. We got the 968. The 348 we shouldn't include. The 986 we got. The 459 we got. Okay. Let's look at some boundary cases, because that's where these things generally go wrong. Let's look at maybe, I'm trying to think. Let's look for 591. Okay, we did get 591, which apparently is also on line 25, column 4. Oh, wait. Oh, line 4, column 25. Or line 5. Yeah, so okay. So we got that one there. Let's check for another one, because there should be one. Yeah, on line 33, which is it's actually line 34 because we're off by 1 here on it. 138, 130. Yeah, so we got that one too. So we're working at the end of the line, which is good. Is there one at the very beginning? Do we get on line 30, or really 29, do we get 78? Let's actually look for that. Oh, we do get that. Oh wait, no. No. It should be on the y being 29, because it's 30, we're off by 1. We're not getting 78. Oh, I'm dumb, because 78 doesn't have a star next to it or anything. So, okay. What numbers are we including that we shouldn't be? Are we off by 1 here? Maybe we're going 1 too far. Let's check that. Let's see if it's just by removing that we get a better solution. No. No, we do not. That goes way too low. So we definitely need the +1 there. Okay, we're skipping over if it's a number, so that doesn't matter. We're skipping over if it's a period, so that doesn't matter. Okay, so we have got to be close. Is our length wrong? I don't think there's a 4-digit number in here, but I haven't looked across the whole thing. So let's see if that fixes it. I think that made it better. There might be a 5-digit number in here. Again, this is a hack. I would not recommend this. Oh, I'm silly. I've got these backwards. Because you want to start it at the largest one, like 5, and then as you know it's shorter, you decrease the length. 540025, 540025. Yeah. So this length calculation came back to bite me in the butt. What are you going to do? You use a non-hacky method. But you know what? This is fine. We got our part 1. All right. And that only took us 25 minutes-ish. All right. Let's do part 2, which isn't too terrible. So, an engineer finds the missing part and installs it in the engine. As the engine springs to life, you jump in the closest gondola. Not going so fast. it has a help, so you pick it up, and the engineer answers. Before you can explain the situation, she suggests you look out the window. Here, there stands the engineer holding a phone. Oh, what the heck? Chrome's just having a good time today. You're going so slowly you haven't even left the station. So you exit the gondola. Alright. The missing part wasn't the only issue. One of the gears in the engine is wrong. A gear is any star symbol that is adjacent to exactly 2 part numbers. Its gear ratio is the result of multiplying those numbers together. So this time you need to find the gear ratio of every gear and add them all up. So a gear is something that has 2 numbers next to it, and it's a star symbol. So in this example, there are 2 gears. There's this gear, because it's this number next to this number with the star, and then there's one down here. There's this number and this number. So you multiply both of those 2 things together. It's like this one times this, and this times this, and then you add up all of those results. Okay. And you can see what the answer we're supposed to get is. But let's go ahead and solve this. So I think we need to modify our neighbor contains special characters, because we need to know if it's the star symbol, right? If what we're next to that we're including is the star symbol. I don't know if the problem says you can be next to multiple symbols. Because if we're next to multiple symbols, we actually need to not early return here. Because maybe we'll find one that we're next to, but then we actually are going to be next to another one that is a star. Glancing at it, it doesn't look like that's the case. It looks like every number is right next to exactly one thing. So maybe I won't check for that. Well, let's see if that works. We can change this return true early to just something else. But what I need to know in this function is it also needs to tell me, are we next to a star? And so we're actually going to use another Onyx feature here called enums to do this for us. So we're going to have a, I'm going to call it a neighbors special, I'm going to have a terrible name here, special characters result. Terrible name, but it's going to be an enum. So enums in Onyx work just like enums in C for the most part. They're just names or values, symbols is what I'm trying to say, associated with values. So one symbol that we could have is no special characters, which would mean that there's no special characters next to this particular symbol. And we can explicitly give that a number using the same double colon syntax. We can also omit it, and it will have the same behavior in C where you increment down. So it'll start at 0. The next one I define will be 1 and 2, and then so on. So we have really 3 results we're going to have here. There's no special characters. There are special characters. Really, actually, I'll say not a star and a star. Right, those are really our 3 cases. And so I'm going to replace this bool with the neighbor special characters result, which could be a much better name. But now we're getting this error saying we expected to return that enum, but instead we're returning a bool. So we have to change our thing here. In this case, we actually don't know which one we are, so let's add a little check for that first. If the board at that particular cell is a star, we need to return one thing, and if the board isn't a star, we return a different thing. So if it's a star, we need to return neighbors, that's not the copy thing, neighbor special character result dot star, and then here neighbor special character result, no star. It's interesting this isn't erroring, and it's erroring down here, but that's fine. Now this is cumbersome, right? you've typed out this whole type name twice now. This is one thing to note about enums. They are a little bit different from C in that way because they're actually scoped into their enum name. And so you can't just say, like in C, you can just say no special characters because it's really just kind of a constant that's just defined. That's not the case in Onyx. They are scoped. However, we know we're supposed to be returning a neighbor special characters result. So instead of having to type this all out, we can actually just delete everything before the dot. So what this is saying is, hey, I know I need to look up this star thing, but I don't, well, and then I also know it's going to come from this return type. So instead of me typing out the whole return type again, just infer that this star is referring to this return type's star value. And so you see this a lot with enums in Onyx. They're generally shortened to put a dot in front of the name and then the actual variant, because in most cases the type can be inferred, right? If we didn't know what type, right? So say I used a feature I haven't introduced yet, but like pound auto, where I'm trying to automatically get the type from the body of the function, right? We get an error saying unable to determine automatic return type because you didn't specify what the type of the star is. But if we know the type of that, we can use it to not have to spell out everything explicitly, which is a little bit nicer. So we'll use that in all of these cases, right? We're now returning that particular type, and let's go use that in here. So we're gonna get our result, and we'll use our trusty switch statement to handle all of the cases. So the first case is that there's no characters or no special characters, in which case we don't want to do anything. The next case is that there is a no star, which just means it's a special character, but it's not a star. In that case, we're going to add that sum, so then we can do our part 1 again. In fact, like before, I'm going to create a part 1 sum and a part 2 sum, because we're going to be doing 2 sums. This one is the part 1 sum. Alright, so that's our part 1, and I'll print it out down here. Oh, not star is what I meant. And then the final case is what happens if we do have a star. Well, in both cases, we're going to add it to our part 1 sum because it's still part of the sum. But now we have to do some special stuff. I'll fix that. It's supposed to be not star. Now we have to know what the other thing on the other side of the star is, right? So we actually know for a fact that there's only going to be ever 2 numbers. I believe that is specified in the problem. I think. Actually, maybe it's not. It says exactly 2 part numbers. So we have to be a little bit clever. So I'm going to try to explain this as quick as I can. So what we're going to need to store is a sort of remembering every gear that we have and then storing all the numbers we've seen that are attached to that gear. So the way that I'm going to choose to do this, I actually keep this pretty simple for today's because I'm running out of time for explaining stuff. So what I'm going to do is I'm just going to have a gear map, and it's going to be actually, I'll explain the other stuff because it's going to make it so much easier. I'm going to use a hash map, which it's just called map in Onyx. And really what I want the first thing to be is like an XY coordinate. So the way I'm going to represent that for today is in a pair, which is exactly what it sounds like. It's like a tuple with only 2 things. And this is going to be the X and the Y coordinate, right? So this is our X and this is our Y. And then that's going to map to a particular number. And I'll make that number a 64-bit number. And that number is actually going to be the product of all the things so far. So we're not going to really store a list of them. Well, actually, no, we do need to store a list of them. So we're going to get even more complicated. It's actually going to be a mapping from pairs to a dynamic array of all the numbers we've seen, right? So like in C++, this would be a map of a pair of int and int to a vector of int. Like that's the equivalent C++ standard template library type. Just this is how you'd spell it out in Onyx. So I'm going to write this last part without explaining as much. But basically, if we know we have a gear, ooh, we actually have a whole other complication. We're going to have to be a little bit longer here even, because what we actually need to know is we need to know where that gear is. If we're going to do it this way where we store this, which we kind of have to, we need to also know where that gear is. So if we get a star, we are going to populate this sort of out parameter, this gear location. I'm going to say gear location is, the way you make a pair is by doing the following. You just put curly braces around the first and the second thing, and then you have to make sure there's a dot in front of it. These are structure literals, because pair is actually just a structure, and so really this is just mapping to the first element and the second element in the structure definition, right? Which you could go look at, but for now, I'm going to create our gear location just on the stack like that, and then we're going to pass in a pointer to our gear location. So if we know we hit a star, we know we have a gear location. So what I'm going to do is I'm going to say, if our gear map has our gear location, then I'm going to get the, I'm going to call it gear numbers, and this is going to be gear map get the gear location. I'm going to array.push onto the gear numbers the number that we currently have, and then I'm going to gear map put, which is how I put something back into the map, at the gear location the gear numbers. And the issue here, I'm running into this error, but if I come into the problems, it says unable to solve for polymorphic variable t given the type that. Okay, so the problem here is actually that map.get returns an optional, which we know is not going to be null here, right? So an optional is something that can or cannot have a value. It's kind of like option in Rust or any of the other languages that have a feature like this. So in our case, we just need to unwrap it because we know we've checked that we have that location, so we know it's safe to get it. The error we're getting now is that we have to pass a 64-bit number, or really I'm saying a 32-bit number. I'll get rid of that. I'll say it's a 64-bit number so then I don't need the cast here. Okay, so that's going to add it to our gear numbers if we already have them, if we've come across this gear before. Otherwise, we're going to create a gear numbers dynamic array. We're just going to make it on the stack. We're going to push our gear into our gear numbers, our number, and then we're going to do the same thing where we put into our gear location the gear numbers. Okay, so that's long-winded, but let's print out our map so we can see it. Okay, so the way I'm going to do this is I'm going to use printf, and if I print out just using like the curly braces and I pass in the gear map, we'll find that it does print it out, but it prints it out in kind of a hard way to read a little bit. It's not too terrible, but I think we're actually going to put a P character here, which P is one of the special format specifiers you can put in here, and this means pretty print. So if I run this, oh, it's actually really not that different. Oh, it's because of how these dynamic arrays are. All right, that's okay. But if I run this with less, we can kind of test for this. So I can see that the gear that's at 1.6, which is this gear, has 12 and 291 in it. The gear that's at, I guess 15.1, which is this one, not that one, this one, is these two numbers. And so that looks like it's working perfectly fine. Out of curiosity, I'm just going to scroll through this. I don't see any that have more than two numbers. So it looks like we could have done the cheater's way, where we don't store them, we just multiply them preemptively. But that's all right. You got to use dynamic arrays as well as hash maps, so nice fun challenge. All right, so now we need to compute that part 2 sum, which maybe I already declared. I already did. Okay. So that part 2 sum, we're just going to loop over everything in our map. The way we do that is using gear map arrow as iter. So I didn't really talk about arrow up here, and it's a whole other thing to talk about, but it's basically like a method call. And so we can just know that that's how we're going to iterate over this, this map. And what we're going to get out of it is a thing that has a dot key to access our location and a dot value to access our array. Well, I only really care about the value component. I just want to know if the value's length is 2. Well, really, actually, I want to know if the value's length is not 2, I want to continue, right? I want to skip this one. Otherwise, I want to add to part 2 sum. So use the plus equals, just it value subscript 0 times it value subscript 1, right? Just the two things that are in the array. And then I can actually move the print line for these things down here, because I'll just compute that before I print anything out. All right, I am starting to lose my voice, but I think we got the right answer. 845848891. All right, that looks correct. So this was a long one, but it covered some interesting stuff in Onyx, right? We talked about enums and how you can implicitly access them and how that's kind of convenient to use. Mentioned struct literals, which I'm sure we'll see a lot more of. We talked about the pipe operator, right? How it feeds input the left-hand side into the first argument of the right-hand side. We talked about maps and dynamic arrays and pairs and all of these like data structure things that you are probably going to have to use. Our parsing was pretty simple. We just used the parseInt. We have this hacky way of getting the length. We could replace that with some kind of math function, but this is good enough for now. We call our function to get our pair. We can switch over an enum. I just kind of took advantage of that, but you can switch over an enum using the same dot syntax as before. And then this is how we used our map, right? We use these kind of methods, which I'm sure I'll talk more about later, but we check to see if we've already seen this gear. If we have, we get the array, push onto it, and put that back into our map. Otherwise, we create a new array, we push on a number, and then put it in the map. And then finally, we have to clear our number out so we don't get duplicates of the same thing. To compute our final part 2 sum, we just loop over everything in the map. We get the value of each thing. We find the things that are only 2 things in length, which I think are all of them. And then we add the first and the second thing, multiply together, add all those up together, and print out our result. So this one was a little bit more involved from Onyx, but it's pretty cool. And hopefully you learned something. I'm gonna take a break before I record day 4, so I might still be a day behind. But yeah, this was a really good problem, and I really enjoyed it.